Now that you learned your library of functions, we need to talk about translating functions. So let's say we have y equals x squared. This is a nice, pretty parabola. So there's a couple ways to teach this. I like to teach it in terms of the vertex or the anchor point. That's why we talked about it before. Let's say we have y equals x squared plus 4. So what we do with that is we're going to move this up 4, and all the y values move up 4, so it moves up 4. So I'm going to call this my vertex. My vertex here is 0, 4. And let's say we have y equals x minus 3 squared. That means you're going to take away 3 from each of the x values. If we were to graph it, we would see that it shifts 3 to the right. So it looks like this. And then if we put those two concepts together and say y equals x minus 3 squared plus 4, then it's going to shift 3 places to the right because of the 0 of 3 and up 4. And it's going to be this pretty parabola here with the vertex at 3, 4. Let me go back over here. This vertex is 3, 0. So let's look at this in an interesting way. I like to teach this in terms of a vertex. So if we have a standard form, we're going to say y equals x minus h squared plus k. This is the formula for a parabola. We can use a similar formula for absolute value. Absolute value. We can use a similar formula for the anchor point on x to the third. We can use a similar formula for a square root graph, x minus h plus k. In each of these formulas, our vertex or anchor point, using what we learned before, our vertex or anchor point is going to be h comma k. So what I want you to notice is we change the sign of h and we keep the sign of k. So if we go back to the last graph, it's y equals x minus 3 squared plus 4. We know that this is a U-shaped graph of parabola from our library of functions, and it has a vertex at 3, 4. So that means we're going to come over here to 3 and go up 4, label our vertex point of 3, 4, and draw a parabola. Now, if this was absolute value, let me give you a second there. Now, if this was absolute value, there was no squared, it's just absolute value, it would be a v, because our library of functions tells us that's a v. If we had the square root graph, y equals the square root of x minus 3 plus 4, it still has the vertex, or let's call this the anchor point, as the anchor point of 3, 4. So it would start in the same place at 3, 4, and we would have the square root graph. So if you think of it in terms of a vertex or an anchor point, it's going to help us out. So let's say we have to sketch, the directions say sketch, y equals x plus 5 squared plus 3. So this is a U-shaped graph. It's a parabola, and our vertex is negative 5, 3. So we change the sign of h and keep the sign of k. So when we sketch this, we're going to go over negative 5, up 3. So this is the point negative 5, 3. And we have a U-shaped graph. Say we have y equals x minus 1 to the third plus 7. So whether you can call them all anchor points, you can call them all vertices. I don't mind. Some people do. But this x to the third graph, we know it looks like this. So it's not technically a vertex. It's technically an anchor point in the middle. It was 0, 0. And what we're doing is we're translating it left or right and up or down. Now this new anchor point or vertex, we're going to change the sign of h to be positive 1. And we're going to keep the sign of k to be positive 7. So our anchor point is at 1, 7. So we're going to come over here to 1 and go up to 7. And we have a x to the third, so that's a half a parabola up and a half a parabola down. let's say y equals the absolute value of x minus 2 plus 6. People want to tell me that the absolute value changes that minus to a plus. It does not. It changes the sign of a number. But that x minus 2 is a binomial. It can't change the sign of that. The absolute value tells us it's a V-shaped graph. So that means we have a vertex. See, we have a change of direction, so that is the vertex. And our vertex in this case is we're going to change the sign of h to be positive 2 and keep the sign of k to be positive 6. And the absolute value tells us it is a v. So here we have positive 2, positive 6, and we have a v for absolute value. So these rules apply to translating all functions. You can use it for all of them. There's an interesting case. People struggle with this case. Notice there's nothing in with the x. So first of all, the x squared tells us it's a U-shaped graph, not a v, but a U-shaped graph. And there's nothing in with the x. So there's technically a 0 there. You could think of this as x plus 0 squared plus 6, in which case our x value is 0, and we're going to keep the sign of k to be 6. So then when we look at this graph, we move right or left 0, and we just move up 6. So let's do this one. Let's say the square root of x plus 5. Now the square root tells me that I have this graph right here, so that's what's important there. And now let's look at the numbers. We have a vertex or an anchor point. In this case, it's an anchor point. So for our anchor point, we're going to change the sign of h to be negative 5. And there's nothing at the end added, so let's consider the fact that that's technically an understood 0. So we have negative 5, 0 as our anchor point. So as we look at the sketch, we're going to come over here to negative 5, and we have the one-sided graph, negative 5, 0. All right, well, that's translations, and we're going to get into transformations, which is the coefficient, which is up and down and compressed and stretched, but that'll be the next video. Have a great day, and I hope that you understand.